All right, let's just dive right into this explainer. We're tearing through the ultimate glossary, acting as your guide to the exact vocabulary you need to confidently defend your architectural choices, whether that's in a portfolio review or a brutal technical interview. We've got a lot of ground to cover today, and honestly, mastering these exact terms is the literal difference between a crystal clear explanation and just kind of waving your hands around.
We've got a massive roadmap ahead. We're hitting Kotlin foundations, object-oriented principles, architecture and patterns, Backend and HTTP, persistence, and wrapping it all up with Android and Compose.
Kicking things off with Section 1, Kotlin Language Foundations.
Think about the absolute bedrock of your codebase. That very first choice you make when declaring a variable. It literally tells future readers whether they're in for some nasty surprises later on. We've got val for locked-in, immutable references, and var for mutable ones. It's just a fact. Reading code is vastly faster when you instantly know what's bolted down and what's allowed to shift around.
So if a senior engineer, or hey, an interviewer, asks why your entities use val, hit them with this. You default to val everywhere because immutability makes things completely predictable. Var, that's the rare exception. You really only pull it out when a framework or some highly specific orchestration absolutely forces your hand. Now this is where Kotlin kind of flips the script on what you might remember from languages like Java. That double equals sign, that's actually your structural check, calling .equals under the hood to compare fields, and honestly, that's exactly what you want 99% of the time to verify if two data classes hold the identical info. You save that triple equal strictly for referential equality, when you need to know, wait, is this the exact same object sitting in memory?
All right, moving right along to Section 2, Object-Oriented Principles.
Okay, let's clear up a classic debate, interface versus abstract class. Look, you grab an abstract class when you actually need to share real state and logic between siblings, like a base entity class managing database IDs. But an interface, that is a pure, uncompromising contract. It completely severs what a thing does from how it does it. And trust me, that decoupling is the magic trick for swapping out implementations without breaking a sweat later on.
And that brings us to polymorphism, specifically why we go all in on sealed classes. Imagine you've got a sealed class for priority. When you call priority.deadline from now, the runtime just steps in and magically grabs the right implementation. Acute, high, low, whatever. No massive, ugly when statements, no spaghetti conditional branching. Just clean, dynamic, runtime dispatch. It's beautiful.
Zooming out a bit, let's hit Section 3, Architecture and Patterns.
Here's the deal with clean architecture. Your domain layer is the absolute VIP. It sits right at the center, totally walled off and protected. It makes the rules. All those outer layers, your Ktor server, your exposed database, they are just there to serve the domain. All dependencies point inward, no exceptions.
I absolutely love this perspective because it's the ultimate defense for using repository and dependency injection patterns. Abstraction buys you total freedom. Since your domain layer only speaks to its own interfaces, you could literally migrate from a Postgres database to an in-memory test database tomorrow, and your actual business logic wouldn't even blink. Zero changes. It's a game changer.
Next up, we're talking Section 4, Backend and HTTP.
We lean heavily on standard HTTP REST principles to keep communication completely predictable. 200s, we're good, success. 400s, the client messed up somewhere, like asking for a totally bogus page. And if you see a 500, yeah, that means the server itself is currently on fire with some unexpected error. It's a universal language, so the client app always knows exactly how to react.
Now, whatever you do, do not mix up these two concepts, authentication versus authorization. Authentication is simply who are you? Think logging in and getting that JWT. Authorization, on the other hand, is what are you actually allowed to do? Once we know who you are you, say, an inspector who has the rights to delete an observation? Auth confirms the identity. Authorization actually gates the actions. Let's dig into the data side. Section 5, Persistence and Databases.
In a modern Kotlin stack, you're usually juggling two different ORMs. On the back end, we use Exposed. It hands us type-safe SQL without dragging in a ton of heavy, magical ORM overhead. But over on the client, that's where Room shines. Google's Android SQL library is crucial there because of its native flow integration. It can literally stream database updates straight to your UI automatically.
But saving data means nothing if it's fragile, right?
Enter database transactions. They are your absolute safety net. They guarantee that a massive multi-table save is an all-or-nothing deal. Let's say you're saving a new tour and all its participants. If just one participant insert fails, boom, the whole thing rolls back. You never ever get stuck with half-saved, corrupted ghost data.
And finally, bringing it all to the user. Section 6, Android, Compose, and Maps.
These are your core front-end building blocks. We've officially tossed out those old clunky XML layouts for Jetpack Compose, using purely declarative functions that instantly react to state. We've got view models, clinging to state through screen rotations, lazy columns effortlessly scrolling massive lists, navigation graphs locking down type-safe routing, and Maps Compose seamlessly weaving Google Maps right into our declarative UI. If you peek into almost any view model, you'll see StateFlow running the show. It guarantees your UI has one single deduplicated source of truth. You have this private mutable flow being fed by the repository, and a public immutable flow that immediately replays that exact state to any new observer. So you rotate your phone, the screen snaps right back into place instantly. It all forms this incredibly satisfying, clean loop, the model view model data flow. Data bubbles up from the repository into the view model and paints the UI state. At the same time, user events, like smashing a save button, flow downward from the UI, through the view model, straight to the repository to kick the whole cycle off again.
So we've covered the whole stack, which leaves me with one massive question for you to chew on. Are your components just anemic, empty data bags, or do they actually enforce the rules of the business they represent? When you walk into that technical defense, remember, your architecture shouldn't just be code that compiles. Through clean architecture, domain-driven design, and Kotlin strict types, it needs to flawlessly mirror the real-world business it serves. Keep that philosophy front and center, and you won't just know what your code does, you'll know exactly why you wrote it. Thanks for hanging out with me on this explainer.